everyone. Today we will be presenting on one of the most important and evolving fields, the information retrieval in healthcare. My name is Vamsi Krishna and my co-presenter name is Srinivasalu Kesavan. Healthcare is an industry that generates vast amount of data on daily basis, from patient records to clinical trials and medical literature. Retrieving the right information at the right time is crucial for decision making, research, and healthcare. In this presentation, we will explore how information retrieval is transforming healthcare and the key technologies enabling this transformation. What we will be covering in this today presentation. Introduction to information retrieval. In this section, we will cover what is IR and why it is important in healthcare. Importance in IR in healthcare. The significance of efficient and information retrieval. And coming to next, applications of IR in healthcare. How IR is applied in different healthcare scenarios. Coming to next, key techniques and methods. The technologies and methodologies powering IR. Here the IR stands for information retrieval, of course. Popular tools and technologies. Commonly used tools in medical IR. Real world use cases. Examples of IR applications in healthcare organizations. Challenges in healthcare IR. Issues that need to be addressed. Future trends are what lies ahead in the field of healthcare IR. And we will end with the conclusion. By the end of this presentation, we hope to provide you a deep understanding of how IR is enhancing healthcare and its potential for further advancements. Coming to the introduction, IR is a process of efficiently retrieving relevant information from large data sets. In healthcare, IR is particularly crucial because medical data is vast, complex, and often unstructured. Key aspects of medical information retrieval include accessing electronic health records efficiently and retrieving relevant research paper for evidence-based medicine, and supporting clinical decision making with real-time insights, and automating information extraction from unstructured medical text. Let us proceed with such an example like imagining a doctor trying to determine the best treatment plan for a patient which is having rare disease. Instead of manually searching through thousands of research paper and clinical trial report, IR power systems can quickly retrieve the most relevant information which improves the decision making and patient outcome. And the importance of healthcare cannot be overstated due to enormous amount of medical data generated daily. The data overload in healthcare, which medical journals, EHRs, and imaging reports, lab results, and clinical trial data will generate petabytes of information annually. Without efficient retrieval mechanism, finding relevant information is like searching for a needle in a haystack, which requires a lot of speed and accuracy. This will delays in accessing medical information can impact patient outcome. Accurately and timely information retrieval is essential for clinical decision making and bridging the gap between data and insights. IR tool extract actionable insights from complex medical data, which improves efficiency for doctors, research, and healthcare providers. The applications of IR in healthcare. IR is widely used and applied in healthcare across multiple domains. Here are some of them. Clinical decision support system, which helps doctor to make informed treatment choices by retrieving relevant medical guidance and research. And the next one is electronic health records search, which enables efficient retrieval of patient history, lab results, and diagnosis from vast hospital database. Coming to third, medical literature search. This is used by researchers to find academic papers, studies, and drug efficiency report. Coming to next, symptom based search and diagnosis support, which is driven by the AI symptom checkers which enabling to retrieve potential diagnosis from medical databases. And next, the drug interaction checking, which identifies potential adverse drug interactions in presentation. And the next, automated medical coding and billing, which enables revenue cycle management by mapping diagnosis to correct billing codes. Here are the key techniques and methods. The information retrieval in healthcare leverages various advanced techniques such as NLP, which converts unstructured medical data into structured data, which helps to extract key terms like diseases, medications, and symptoms. And next, the name entity recognition, which automatically identifies and categorizes medical terms in clinical text. For example, extracting hypertension and atenolol from medical record. And next, the query expansion, which improves search results by adding medical synonyms, abbreviations, and alternative terms. For example, searching for heart attack also retrieves results for myocardial infarction. Coming to next, semantic search, which goes beyond key matching to understand context and meaning. For example, searching for joint pain may retrieve results related to arthritis or rheumatism. Coming to next, ontology based search, which standardizes terminology and relationship between medical concepts, which helps to retrieve relevant results even when different words are used. Ending with the medical machine learning and deep learning models, which is used for predicting patient outcomes, clustering medical records, and document classification. Model like BioBed and Clinical Bed, which enhance medical text processing.
Thank you, Vamshi, for that great overview. Hello, everyone. I'm Srinivas Lukeswan. Now, I will take you through some of the key techniques and methods that make information retrieval work effectively in healthcare. Let's begin with natural language processing. In healthcare, a huge amount of data is written in free-form text like doctor's notes or patient records, and NLP helps us make sense of that. It does this by breaking down the text through processing like tokenization, sentence segmentation, and syntactic analysis, making it easier for systems to search and understand what's written. Next, we use something called named entity recognition. This technique scans the text and identifies specific medical terms such as illness, medications, or symptoms. For example, it can pick out terms like high blood pressure from a patient's record and recognize their meanings. This makes searching medical text much more precise. Next, query expansion. It improves a user's search by adding synonyms or related medical terms. So even if someone looks for sugar disease, the system can also look for diabetes. This is the continuation of key techniques and methods. Semantic search. This looks at the meaning behind the search, not just keywords. It helps to find relevant results even if the exact words aren't used. For example, if you search for high blood sugar, you might still retrieve documents about hyperglycemia because the system understands the connection between those terms. Ontology. Ontologies helps to connect related medical terms. So if someone searches pain, it might also find headache or cramps. Machine learning and deep learning. They are used to classify records, make predictions, and improve accuracy. Models like BioBert or clinical birth are used to train data so they understand healthcare language better. Popular tools and technologies. Here are some tools commonly used in IR healthcare: clinical text analysis and knowledge extraction system. This is an NLP system specially designed for extracting information from clinical texts like doctor notes, discharge summaries, and radiology reports. It helps to convert unstructured data into structured data that IR can work with it. BioBert. This is a deep learning language model pre-trained on large scale of biomedical text. It improves the accuracy of search and classification tasks in healthcare by understanding medical technology better than general purpose models like BERT. MetaMap. MetaMap links medical text to medical terms. PubMed. This is one of the most popular search engines for medical literature. It uses advanced AI IR techniques to help doctors and researchers quickly to find relevant studies, trials, and publications based on their queries. Unified Medical Language System. It is a comprehensive ontology that connects and standardizes over 200 medical vocabularies. It helps in understanding relationships between medical concepts and improve the relevance of such results. Microsoft Azure Health Bot. It is a AI bot it uses to answer health related questions. These tools are the backbone of many IR in healthcare systems. Whether it's for research, clinical decision making, or patient interactions, they make it easier to process, understand, and retrieve complex medical information efficiently. Let's now take a look at some real world applications of IR in healthcare. These examples shows how IR is being used in practice to improve patient care, diagnostics, and research. Mayo Clinic. It's a patient record analysis. The Mayo Clinic uses NLP and IR to extract valuable information from unstructured clinical notes, things like patient histories. This supports better diagnostics and more effective care planning as a doctor can quickly find what they need from a large volume of data. IBM Watson for oncology. IBM Watson supports oncologists by retrieving and analyzing vast amount of medical literature, clinical trials, and patient history. It uses this information to suggest personalized treatment options by helping doctors make more informed decisions. Informaticas. It is a symptom checker. This is an AI-based tool that uses IR to match patient symptoms to possible medical conditions. It leverages a structured medical knowledge base to assist user in identify what might be wrong, which is especially helpful in telemedicine. PubMed search engine. It is a widely used IR platform that enables doctors and researchers to retrieve relevant medical literature. It supports both keyword-based and semantic search, making it easier to find most relevant research papers or clinical trials quickly. Google Health or DeepMind. Clinical Notes Understanding DeepMind under Google Health. It uses deep learning to combine with IR to understand and summarize long patient records. This technology helps to reduce the burden on medical staff by extracting key details and supporting hospital workflows. Challenges. While IR in healthcare has made a huge progress, but there are still several challenges that need to be addressed to make it more reliable and effective. Data privacy and security. Healthcare data is very private. IR systems must protect this data and follow the rules like HIPAA to keep patient information safe. Unstructured medical text. A lot of medical information is written in a free text like doctor notes or reports. This makes it hard for machines to understand without using special techniques like NLP. Complex medical terminology. Medical terms are complicated. There are many abbreviations and technical words which can be hard for a system to process correctly. Interoperability issues. Different hospitals and clinics uses different systems. IR tool must work across all of them, which can be difficult. High accuracy. In healthcare, accuracy is extremely important. If IR systems make mistake, it could affect patient care. Limited labeled data for training. AI need a lot of labeled example to learn well. But in healthcare, that kind of data is hard to get because of privacy and the effort it takes to label records. Future trends. Let's look at some excited trends in IR for healthcare. Large language models. AI models like GPT and BioBert are being used in healthcare to better understand medical language and improve search results. Conversational IR systems. Chatbot are being used more in hospitals. They let patients and doctors ask questions in natural language and get helpful answers. Multimodal information retrieval. Future systems won't just search text, they'll use images, videos, and sounds too. For example, combining x rays with the patient's history. Real time IR from wearable and devices. Smartwatches and medical devices can send real time health data, which IR can use to spot early health problems. Explainable IR systems. In future, IR systems will explain how they found results. This helps doctors to trust the system more. Personalized healthcare search. Just like we get personalized ads, IR will give results based on a patient's medical history to make them more useful. AI powered clinical decision support. IR will help doctors to make better decisions by quickly finding the latest research, treatments, and similar cases. These trends shows how IR is becoming not just smarter, but more human-friendly, real-time, and essential in supporting to next generation healthcare systems. To wrap up the presentation, let's quickly summarize the key points we have covered. IR is changing healthcare by giving fast accuracy access to medical data. It supports better decisions, research, and patient care techniques like NLP, NER, and deep learning are making this possible. Even though there are challenges, the potential is huge. And with the future advancements, IR will keep getting smarter, faster, and more helpful. Thank you so much. I hope this gave you a clear picture of how IR is shaping the future of healthcare.